Yes. So good evening, guys. We'll move on with our proofs. I think in the last session we had done this problem, and there was an extra problem that was given just to check if there is something wrong in this proof. And some of you said that there is. I hope everybody saw this extra problem. Just give me a thumbs up or a clap so that I can know that you guys. Okay. All right.
So I don't think we did it in class.
Sorry, say that again.
I don't think we did it in class.
No, we did not do this in class. This was put up in the Google Classroom.
Yeah.
Yeah. Yeah. So some of you. Sorry, I can't hear you clearly. Can you speak a little louder, Parth?
So was the solution put in Google Classroom or
Just the question. The entire proof basically was given in the Google Classroom. And what I wanted to know is, is there any flaw in this particular proof? And anyone would like to comment here? Is there a flaw in this? Those who went through it.
Teacher?
Yes, Venkat.
So I don't think there's any flaw, but in the induction step, I used a different method.
I saw your post. Yes, I'll come back to you on that.
So can you show the induction step here?
No, I don't want to spend time on that because this I was expecting that students would go through. So I just want a quick answer, is correct or not. Meanwhile, can the volunteers let in participants from the waiting room? Nivedita has been there since some time.
So what is that kind of C that is it?
Where C? Oh, that is N choose R. N choose R.
Oh.
I use binomial theorem only, right?
Right.
Okay. So.
Is Devansh here? Devansh hasn't joined. All right. So here, guys, if you look at this proof is not. Yes, Malay had commented. Malay, can you tell what is the problem in this proof?
Yes, sir. Sir, in proving our claim in the induction step that k plus 1 to the power a minus 1 is divisible by k, we have not used our statement in the induction hypothesis.
Right. So this is one of the most important thing in induction. Many a times people start with induction and then they start with the induction step and then they do element, mere algebra. So what I have done here is mere algebra. But the thing is, I have not used induction hypothesis anywhere. And if you remember, in induction, the main thing that we need to do is we have to use induction hypothesis. Otherwise, we are not showing that it is proved by induction. If you want to just do algebra, then there is no point in having induction hypothesis and base case, no?
So this is a regular proof, not a.
This is a normal proof, not proof by induction. So if the question is prove by induction, this would fetch 0. I mean, or maybe just some marks to encourage you. But this wouldn't be correct because we need to use induction hypothesis. Otherwise, we are not showing how k will result in k plus 1. Okay. So that was the biggest flaw. And of course, there were some minor things like as compared to we'll prove this using mathematical induction on N or A. We need to decide which one will we do mathematical induction on. Should we do on N or should we do on A?
A.
Can you wait for a minute?
On N.
N will be.
And
We can
I think on A is also.
on N. Why? Because N is the favorite letter where will be. So here we did induction on N. Now you can also think what will happen if you do induction on A, whether it will go through or it will not go through and so on. So many times when we have two variables, it may be possible that we can do induction on either of them, but not always.
So we can do on both
Not
also.
always. Okay. So here I have done induction on both. In some cases it will go through. It will, you can do induction on either of the variables, but not always. So we need to think, where do we need to do induction on? Okay. And that, how do you know where to do which variable to do induction on? It comes through a bit of practice. Okay. All right. And then there were some problems which or maybe there are some problems which I'm going to just quickly share with you, and I'll put most of them on the Google Classroom for you to get a hang of it. Okay. So if you look here, let me use.
Sir, I can't see. Okay, I can see it now.
You can see, right? Okay. So the first one, these problems are typical problems on induction. And here you just need to do algebraic manipulation, and then things become, my screen has frozen, so I'll have to reboot my system. Can you guys take a screenshot of this page?
Yes, sir.
Yeah, just take a screenshot. I'll wait for 30 seconds. I need to reboot my system because I can't see anything. So take it and just read those problems. I've divided them into 3 categories. The ones that require elementary algebra, the ones where we need to do some kind of manipulation. And the third one is something where we may not be able to use algebra as we are using in the first one. Okay. So I'm assuming everybody took a screenshot. I'm going to reboot my system. Okay. Yes, I'm back. Volunteers, can you just make me the co-host? Nitesh. Yeah, thank you. I hope you took a screenshot. I need to just log in once again. Yeah. So we'll quickly discuss how these problems are different in, with respect to how you use proof by mathematical induction. So the first 3 are pretty straightforward problems. That is, if you write the induction hypothesis and you use the base case, there is nothing great that you have to do. You just have to follow those steps and you get through. Okay. So this is something that I expect everybody to do. In case you are not able to do, just go back to the video and get a better understanding of it. We will do one of these problems now quickly. Okay. And Madhav, question?
Sir, I just read that all the first 6 questions, and except that first one, when I just saw it from 2nd to 6th, can we also prove it without induction?
Oh yes. Oh yes, absolutely. So like I said, in the last class, why are we doing this using induction? There is no hard and fast rule that we have to use induction, but we need to know how to use induction, in which are the problems where induction can be used. So every problem, there may be more than one ways to prove that particular problem, and that is very likely. But we are doing this just for the sake of getting a strong hold on induction. Okay,
Oh, okay.
Madhav? Yeah.
Okay.
Sir, the ninth problem is solved in class.
Then
It's the same problem, it's just differently phrased.
I don't think so. Oh yeah. This one
So
we
it's
solved.
done.
Yes. I was looking
Yeah.
at the pen. So this one we did. You see, these are slightly different problems, and this one as well. This one is one of my favorite problems because you can use induction, you can use contradiction, you can use pigeonhole principle. There are different ways in which you can prove the last one. So those who are introduced to more than one proof technique, you can try that. But right now, we are going to try solving this one. Okay, prove that sum of n minus 2, 180 into n minus 2. How are we going to do it? Right.
Sir,
Yeah.
sir, can you tell what's the meaning of that eighth question?
Eighth one.
Yeah, sir.
Eighth is yes. So let's do one thing. Let's do the fifth one and eighth one, and then we will go. Okay.
Oh,
Vinay
okay.
ji.
I just couldn't
Yeah.
understand the meaning.
So what is that 180-degree turn day?
I'll explain. Say that
Vinay ji,
Nitish,
your voice is
what-
getting a crack.
Are others able to hear me clearly?
Sir, it's breaking.
No, sir.
It's breaking.
Sir,
Yes, sir, it's breaking.
Breaking.
It's slightly breaking, sir.
All right. Let me switch. Okay. Let me switch to. Thank you, Nitesh. Let me switch to another connection. Yeah, it will be good if one of you can keep your video on, so that when I see your video not moving, then I know that there is a problem with my connection. Thank you, Dhirav. All right. So yes, so we will do the fifth one. Let me just copy the fifth one. Right. And yeah, prove that this. Now I hope everybody is aware about this. That is, if you take any polygon which has n sides, right? So if you have a 3-sided polygon, then it is 180 into 3 minus 2 is the sum of all the angles. If you have a 4-sided polygon, it is 180 into 4 minus 2. 5-sided will be 180 into 5 minus 2. So n-sided will be 180 into n minus 2. And this is what we need to prove using mathematical induction. Parth, you have a question?
No, sir, I got that.
Smithali?
Answer, sir.
Okay, Achyutan?
Sir, for the 10th question, n has to be greater than 1, right?
Yeah, we'll discuss about 10. Yeah, n has to be greater than 1. Yeah. Let's work on this one. Soham, question?
Yes, sir. So
Tell me.
I was trying to do the problem, but I have done induction hypothesis and base case, but I am not able to get the induction step.
So why don't you start with the induction hypothesis? You tell, and we will continue. Tell me.
Sir, in this problem, can we use the fact that sum of our external angles is 360 or no?
You can do whatever you want. It's just that you need to follow induction. Okay. Soham, continue.
Yes, sir. So our induction hypothesis will be, let us assume that our claim is true for an arbitrary but a particular k.
Okay. What you said is perfect. I'm just avoiding writing.
Yes.
all the things. But before
Yes.
that, we need to say induction on n.
Yes, induction on.
Continue.
Yes. Then our base case will be 3. So n is equal to 3, and then our means
It
yes,
works.
it will be true.
Induction
But
step.
I'm not getting the induction step.
Induction step. So let's try to see what do we need to prove. To prove that, what do we need to prove, Soham?
Sum of all angles of n set polygon is 180 times n minus 2.
Tell me in terms of k plus 1.
Yeah. So in terms of 180 multiplied by k plus 1 minus 2.
So can I say to prove that sum of all angles of a k plus 1 sided polygon
is equal to
is 180 into k
plus 1 minus 2.
Which is nothing but 180 into k minus 1.
Yes.
Okay, this is our goal. This is what we need to prove.
Yes.
Right?
Sir.
Now what do we do?
Yes, I'm not getting that
okay.
only.
So at least you got until this. This is good. Okay.
Yes,
Shaurya,
sir.
question?
No, sir, I
Shaurya?
wanted to answer the question.
Okay, go ahead, Shaurya.
Sir, for the induction step, what we can do is we know that we have a polygon with k sides, and our induction hypothesis is that the statement is valid in it.
For
So-
induction hypothesis, for a k-sided polygon, it will be 180 into k minus 2.
So now what we can do is in any side of the polygon. So if you can draw some part of such a polygon, it will be helpful.
Say first point, and this is the kth point. Okay, you have some k-sided polygon.
So now what we do is if we add a triangle on any one side, just extend the sides to form a triangle, like the kth point. Yes, like that. And we erase the side that is in between.
This one.
Yes, so now what we get is a k plus 1 sided polygon.
And
so what we observe from this is the sum of angle. Now it becomes the original sum plus 180 degree, since that triangle's angle sum is 180 degree. So 180
plus
into
180.
k minus 2 plus 180, and that's 180 into k minus 1.
Like this.
Yes, sir.
Okay. Smithali, is this wanted to say, or you have a different argument?
No, sir, the same.
Parth, same argument or different?
So, same.
Anyone who has raised hand who has a different
Yes,
argument,
sir.
please. Raghav, different. Okay, go ahead.
Sir, in the base case, when we assume that k is equal to 3, we got the answer is 180 degree, like in a triangle. So if there we had another example, like k is equal to 4.
Actually,
and-
base case should be n equals, not k equals.
Okay, sir. So if in the base case we say, sorry, in
No,
the base
go ahead.
case we say n is equal to 4, then we find out that the difference between n is equal to 3 and n is equal to 4, the equation gives the difference of 180 degree, and so on for even n is equal to 5. So if in the base case only we say that 180 n minus 1, that is for k plus 1, for example. So we in the induction step we could give a case that 180 into k minus 1 minus 180 into k minus 2 is equal to 180.
So Raghav, we cannot argue in that way, because when you are making that argument, you are assuming that it is going to go in that way, that the difference will always be
yes, sir.
180. But that is what we need to prove. We cannot take it for granted, you see. Okay. Achyutan, question?
No, sir, I have a it's the same solution, but it's done in a slightly different way. Instead of proving that the sum of angles is 180 to k 180 to k minus 2, we can prove that an n-sided polygon can be divided into n minus 2 triangles, and then we'll get the same result. And for proving that,
But then we can have concave polygons and all, Achyutan.
yeah, but we'll still get a triangle. The triangle might not lie in the interior, but we'll still get a triangle.
Even if you get something like this,
Yeah.
then you are saying we'll divide it like this, like that.
Yeah.
So then you can have problems like these. For example, if you have a hexagon, let us say, you have a regular hexagon and you divide this into 6 triangles. Okay. You say the angle sum is 180 into 6, which is 1080. Is that correct? Not 1080, right? Is it correct, Achyutan?
Yeah.
No, because we are counting the interior part. We are adding
Because
60 extra.
it is 360 here and 360 here, 2 quadrilaterals. So it is 720. Now, when you are doing 1080, it is sum of these angles as well. You see?
No, all 3 points have to lie on all 3 points have to be vertices of the what do you call it? The polygon.
So you do something like this.
Yeah, from one point, draw what do you say? Draw lines to all the other sides, and then
All the other vertices.
Yeah.
And then you add.
So you draw all the diagonals.
But then where are we using induction hypothesis over here?
No, we will assume that this holds good for k. Then for k plus 1, we'll make it into a triangle plus a k-sided polygon.
So which is what is done here, no? Right now somebody gave this proof.
Yeah. So that's why I said it's the same proof, but we're approaching it in a different way. It's the same proof, but instead of
no. So I'll tell you why it is not different, because when you are saying you draw these lines, okay, when you are saying you draw these lines, you don't have to do that. Induction hypothesis gives you the entire thing for free. You don't have to draw all these. You can just assume that it is true. You draw these lines and take all that effort when you don't use induction, when you have to use an argument, some deduction to prove. So you don't have to use that, but it's a good way to prove it if you are not using induction. Okay, so unless you have questions, please lower your hands. Madhav, question?
Yes, sir. Like I understood all these. Just to ask, sir, if not induction, we can use that extend all to straight lines, then including exterior angle 180 and minus 360, the sum of exterior angles, like that also we can prove, right?
You can do that. Okay. So this proof is good, but this proof is not considered the best one, and I'll tell you why. Which is why I put these 2 problems in a different category. Okay, and let me tell you what is kind of slightly missing in that. Now, if you remember in the first session, I said that induction is an argument between 2 people, right? You and the adversary. You tell the adversary that the angle sum is 180 into n minus 2. The adversary does not believe. So what do? You tell the adversary to give you a k that he think of the most difficult k. So the adversary gives k. Then you say, let's assume that it works for k, and you're going to show for k plus 1, right? Now the problem is when you say add a point, or add a point k plus 1 and join it to the next 2 sides, right? So that becomes, okay, where are you adding the point? What will happen if you join the sides? These questions can be coming up. Now
So
in this case,
do what you did earlier, like me asking to draw.
Can I finish, Omkar? Yes, that's what we are going to do. So you, instead of adding a point, what you do is you ask the adversary to give you a k plus 1 sided polygon. K plus 1 sided polygon. And let's say that this is the k plus 1th vertex. You tell the adversary, you take away the k plus 1th vertex and all the sides that are connected to k plus 1 vertex. So this will naturally take off only 2 sides, because every point will be connected to 2 other points. Every vertex will be connected to 2 other vertices. So it takes away 2, and then what is left is a k-sided polygon. Now you say that in a k-sided polygon, you have 180 into k minus 2. Then you say what you had taken off this k plus 1th vertex, place it back. And the edges that were incident on it, place it back as it were earlier. And then you ask the adversary, okay, so now tell me what is the angle that got missing from here? And he says that is 180 degrees. So then you say, okay, now it has to be 180 into k minus 2 plus 180. Okay, so this way of arguing is a better way of arguing than saying add k plus 1th vertex, because in this problem we know that there are 2 edges incident on k plus 1, but there would be problems where you have a lot of, in graph theory you might come across this, a lot of vertices, lot of edges incident to the vertices. So we don't know things for clear over there. So you don't know how many edges will be there and so on. So it is always safe in such cases to say that consider a k plus 1-sided polygon, lift the k plus 1 vertex, what goes off is a triangle, add it back. So what comes back is a triangle. We know by base case, for triangle it is 180. So it has to be 180 which is added, and then it is true. Okay. So just keep that in mind. And similarly, you can try this, the number of diagonals for an n-sided polygon is n into n minus 3 by 2. Again, over there, take ask the adversary to give you the most difficult k plus 1-sided polygon. Take off the k plus 1th vertex. What will remain is a k-sided polygon. Use the induction hypothesis. Add the k plus 1th vertex. See what happens when you add the k plus 1th vertex. How many new diagonals are formed. Argue and then prove it. So these are pretty closely related to each other, which is why I put them here. Okay. Now 7, 8, and 10 are slightly different, but somebody asked me to explain this one. So let me just do this. You have a n by n by n cube. It's like a Rubik's cube, a 4 by 4 by 4, a 7 by 7 by 7, whatever. And to cut all the cubes, so all the cubes of length 1 unit. Okay. Now, actually, in a Rubik's cube, inside you have all those, screws and nuts. So don't think about that. Think about a actual solid Rubik's cube, which is filled up with small cubes. Now, if you want to cut out every single cube out of that, every single cube using a knife with which, let's say that you cut this and then one layer comes out and make another cut, another layer comes out and so on. So suppose you want to do that is cut out every cube, every small cube. What is the number of cuts that you need? Okay, the number of cuts that you need will be 3 into n minus 1 cuts. What does that mean? Take a 3 by 3 by 3 cube, right? You see the centermost cube. The centermost cube has 6 faces which are covered by other cubes. So if you want to take that cube out, then you have to make 6 cuts, then only it comes out. But if it is a corner cube, let us say, a corner cube, 3 faces are out, 3 faces are in. If you make 3 cuts, the corner cube will come out. But for the centermost, you need 6 cuts. So 6 is nothing but 3 multiplied by 3 minus 1.
Sir, actually, we are making 2 cuts in all 3 dimensions.
Exactly. 2 along the x-axis, 2 along the y, 2 along the z. Okay. So that is what it says. So if you have an n by n cube, you need to show that you can do this in these many cuts.
Yes, sir.
Now,
I got it, sir.
Okay. So in these problems, you will see that your your jugglery with algebra may not work, and it is there you can actually bring in induction. Parth, you have a question?
Yes, sir. Sir, if we cut a layer, then the so like the two forming parts will be separated, but they'll still be together, right? So if we make
Yeah,
a
you can,
second cut,
even
then
if they are
both of them
separated,
will
you
go.
can bring them together and make another cut.
So then I
Okay.
got it.
Yeah. Madhav, question?
No, sir, like I think I got it. Not exactly
Oh.
sure.
Yeah, you should write it down and then see how it is. Okay. Raghav, question? If not, just lower your hand. Right. So these are similar, problems which you can take in for induction. And if time permits, we'll have another doubts clearing session where we can try these. I would now like to move on to something called as proof by contradiction. Proof by contradiction is a proof technique which is introduced usually in schools, and typically you do 2 or 3 types of problems, 2 or 3 problems, not even types. Let me just tell you how proof by contradiction works. Let's say that there are A and B, two people. A is accused of a crime, okay, but A is innocent. Okay, so A wants to prove his or her innocence, and B is accusing A of the crime, right? So A's lawyer is saying, let us assume that A is guilty. Okay. Now he's saying, let's assume A is guilty, but A is not guilty. A is innocent. So he assumes the opposite of what is true. Unlike induction, where you assume a smaller case of the original problem is true, right? In contradiction, you assume the opposite is true. And once you assume the opposite is true, you come up with some logical statements after this. If this is true, then this has to be true. If this is true, then this has to be true. If this is true, then this has to be true. But then finally, you will reach a contradiction. For example, let's say that A is accused of eating a red color lollipop. Okay, red color lollipop. So A has got a younger sibling who is saying, A took the red color lollipop. So A is saying, okay, you think I took the red color lollipop? I ate it. You can just, check. If I would have eaten it, then my tongue should be red in color. Now you open your mouth and say that, is it red in color? No. So from that, what can we conclude? We can conclude that our assumption, what A ate the lollipop, is incorrect. Therefore, A is innocent. Okay. So it is this kind of contradiction that you reach in proof by contradiction. So you contradict something which is very logical. Okay. And then you say that this is done. So this is the basic structure of contradiction. Now let's take a problem to start with in contradiction. Let's say prove that square root of 13 is irrational. Okay. Let's say that we need to prove square root of 13 is irrational.
Sir, first we can take it to be rational, which can be expressed in the form P by Q, where P and Q are co-prime. Then we can show.
I have heard this song somewhere. Yes, same song. Tell me, have you done this proof in school, Madhav?
Oh, yeah, sir.
You are done. Okay, okay.
Sir, it's done in most of the schools.
Sir, what
In
did he
most
say?
schools. Yes. Yes, Davin.
What did he say, sir?
He said, he started saying the proof that was injected into his blood. He started. I'm just joking, Madhav. Okay. So before we start with this, there was a very good question that in the other batch a student asked. Okay, Venkat, you have a question?
No, so I raised my hand to answer.
Okay. So in the other batch, a student asked, can't we just say that there is no number whose square is 13? So 13 is irrational. No, he said that after we wrote all the proof. And there were some of us like, oh my God, why did we spend so much time writing this? Can't we just say that 3 square is 9, 4 square is 16? You don't see a number whose square is 13. So 13 is irrational. Does that make sense? Yes?
We're
No, sir.
only checking
No,
the natural.
Barely checking natural numbers. You can't checking decimals.
You're
So actually,
infinite numbers. You're skipping infinite numbers.
I am skipping infinite numbers. I see. Okay. So this was another point that came in. That is, between 3 and 4, you have numbers like these, numbers like these, and so on. And maybe the square of one such number is 13. You never know.
But that
You'll have to show that.
Rational, right? Because no
Sorry?
square ends with 3.
Who was that? Madhav?
Yes, sir. So
Yes.
if it is rational, then the square can't end with 3, right? So like that.
You
also
take 12.25. Square root of 12.25 is 3.5.
Yes, sir. Yes, sir.
Right?
If it's
So,
a decimal, then the square has to be on a decimal, terminating
right.
decimal.
Now, what I'm trying to say is that there exists a decimal number which is the square of another number, another decimal number. So what we need to show is that when you take square root of 13, it will be non-terminating and non-recurring. Non-terminating and non-recurring. Because if it is terminating or recurring, then it is going to be a rational number. It is not an irrational number. I have a slight problem the way this is done in most schools. I won't say all schools, most schools. Because in most schools, this is directly, you directly get a proof and then we feel that, oh, I know how to write this down. Okay. So let us start with Devashri, you have a question?
No, sir, for the proof.
Proof. Okay, Devashri, go ahead. How do I start?
Sir, as this is the proof by contradiction, first we will assume that root 13 is as rational number and write as A upon B.
Assume root 13 is rational. Okay, my request is when somebody is going to say a proof, others don't interrupt. If you wish to say something, just do a raise hand. Okay. Assume root 13 is rational. This implies that root 13 can be written as, yes, Devashri?
A by B.
A by B. And then?
Now we have to square both the sides.
Square both sides, you get A square by B square. And then?
So we can write that A square is 13.
13B square is A square. And then?
So here we can 13 will divide A square. So 13 is a factor of A square.
13 divides A square. Therefore, 13 is a factor of A.
Yes, sir.
So, and then
we'll similarly do same as. Sir, give me a minute.
sure. So until then, can I just ask Madhav?
Yes,
Madhav? Yes, Madhav.
Sir,
Continue.
you're asking me to tell it?
Yeah, continue.
Sir, I think first she missed the small point. We can add that where A and B are co-prime.
Okay, where
Or else we can't.
B are co-prime.
We should also add A and B are integers.
Yes.
And B is not equal to 0.
Yes, sir. A and B are integers
and
and B not
B
equal to 0.
belong to the set of integers and B not equal to 0. Okay. Okay. And then Madhav, continue.
Yes, sir. Now we can write A square as some like sir, or A as 13m, just to show that A is a factor of 13 is a factor of A.
Wait. How? So I didn't get this. How is 13 a factor of A? Shouldn't I can agree that 13 is a factor of a square. How do you say that 13 is a factor of a?
Because if
Madhav?
the prime number is a factor of another number square, then that is also a factor
Okay.
of the square root.
So this implies that 13 is a factor of a. Davin, you don't agree with Madhav, or you want to complete the proof?
I want to tell something, sir. Say
You
instead
want
of
to?
13, it's 9.
If it is 9.
So let it be 9. So if 9b squared is equal to a squared, 9 divides a squared. So, but that does not mean that 9 divides a.
So because 9 is not a prime.
So he said that, Davin, this
Okay,
will happen.
Okay, if 9 is not a prime, then 21 is not a prime. How?
Yeah, because then there should be a 3 and a 7 in the prime factorization.
Davin, good or not good?
Sir, what, sir?
No, are you clear why this is okay, or you still have a
No,
argument?
sir. I just wanted to tell that if 13 is a prime, then okay, understand. But
Okay.
21 is not a prime.
Yes.
Then,
Yes.
how is
Yes.
it?
So for instance, I can say that 12 divides 6 square, but that does not mean 12 divides 6, something like that, right? All right. So Madhav, continue. 13 is a factor of a. Then
Sir, so now we can write a as 13 into m or p or any other integer.
a is equal to 13 into m. Okay.
Oh yeah, sir. Sir, so now we can say that a square is equal to 169m, or better we can write a square is equal to 13m, sir. That's also
A
fine. Yeah.
square is equal to 13m the whole square.
No, sir, we can take, instead of taking a as 13m, we can take a square as 13m, because 13 is also a factor of a square, right?
Okay, so a square is 13m. Okay.
Yes, sir. So now we can say that 13b square is equal to 13m. Or
13b
better,
square
13
is equal to
cancel, sir.
13m.
Yes, sir. Oh, sorry, sir. Better we take a is 13m, because 13 will get cancelled here. No use.
Day. A
Sorry,
is 13m. So a
Yes, sir.
square is 169m square.
So 13 and 13 will get cancelled, sir. So we can say that b square is equal to 13m square. So here 13 will divide b square, which implies 13 divides b.
13 divides b square. This implies 13 divides b.
So we can say now a and b have got another factor, which is 13, which contradicts our assumption that a and b are co-prime.
Co-prime.
A by b,
Right.
hence root 13 can't be expressed in the form a by b, so it's irrational.
Correct. Correct. Good, good, good. So this makes it pretty straightforward. Those who have raised hands, if you have doubts, you can keep your hand raised. Otherwise, I'll request you to lower your hands. Panchul, doubt?
Yes, sir.
Tell me.
Sir, here where we wrote like 13 is a factor of a square.
Yeah.
And after that, we wrote that therefore 13 is also a factor of a.
Yes.
This means that a is a prime number.
No. 52. 13 is a factor of 52.
Sir, first I could not understand like how is if 13 is a factor of, oh, okay. Oh, yes, sir. I understood, sir.
Okay. Smitali, question?
Sir, I wanted to add up that what we use, that if 13 divides a square, then 13 is a factor of a. That is nothing but the Euclid's limit.
Rituparna.
Sir, I didn't understand why we are doing so much, sir. Like, why can't we just say like
13 is irrational. Root 13 is
There's always the
sir,
possibility.
why can't we just write root 13 in the form of a by b as root 13 by 1, and then we can just say rational number. Then as a rational number, both p and q should be integers, but then here root 13 is not integer, so it's irrational.
I see. So it's saying, okay, root 13 upon 1, this is a by b, but we have said a and b are integers. This is not happening, so hence contradiction. Ritvik, you have a comment on this?
No, I have a question.
Question, okay. Does anyone want to answer this question? Why can't we just end it here?
I think I
yes,
can try to answer
can
that.
Okay, Ritvik,
Sir,
go ahead.
I think you can change the value of b such that a will become an integer. You know, it can have anything. So if you change the value of b change the value of a in the same way such that a can become an integer, and there are infinite values, and some value can make root 13 an integer. So we cannot say
Right. So let me just come back to you, Ritvik, in a moment. Rituparna, what he's saying is, see, a by b, this need not be the simplest form of a by b. And this is not the simplest form of a by b because this is not a, integer. And maybe you square it, or maybe you multiply it by some other number, and then we can get two integers. Maybe that is possible. In reality, it is not possible, but we need to establish that. We cannot say that, okay, a is root 13, because the simplest form might be something we don't know. Okay.
One more thing.
Yes, I got it.
So one more thing.
Yes,
Sir,
Omkar.
as long as A and B are rational, that makes A by B rational. So it
A
doesn't
and B
have
are
to be
rational.
integers. I'm saying that if A and B are rational, then the whole thing is rational. It doesn't have to be integers.
Oh, they have to be. You know why? Because you can have, you can have continued fractions and all. So in continued fractions, it will go infinitely, but then that's also a fraction. I mean,
So then even there could be some series as integers that will
Yeah.
also go infinitely.
so if you take rational numbers, okay, so this is interesting. So if you take rational numbers, then you simplify that and you will end up getting a fraction like this. You'll end up getting a rational number, right? So why don't we say it is rational? Okay, I'll think about it. Questions, Ritvik, question?
Yes, sir. Yes.
Tell me.
Sir, if you want to prove that root 15 is irrational, like here in this
Good
step
question.
we say 13.
Okay, so
Yeah,
if I
like
can
it
put
is-
Ritvik's questions in a different way, saying here 13 was prime, but what if we have a composite number, right?
Yeah,
Right?
yeah.
How do we deal with it? And maybe that composite number is something like, which is even as well.
Yeah.
So how do
The
we
square
do
root
it?
2 is
No, I
not
think for root
is irrational.
12, sir, I think for root 12 you can take it as 2 into root 3, and root 3 you
Yes, sir.
can
We can
prove
split
as
it into
irrational.
different
You
groups.
can do it
Yeah,
square
but
root 2 into square root 6.
If somebody is saying this is 2 root 3, then you need to first prove that root 3 is irrational.
Yeah.
Second,
But
you
sir-
need to prove that a product of rational and irrational is irrational. Then you can say that root 12 is irrational if this is the root that they want to take. Otherwise, take square root of 12, do this process, do some slight manipulation, and then you will get there. So this you can take
we
as a,
can do it
this
right?
was exactly one question that another student asked in the other batch. What if we have a composite number? Okay, I think you should be able to write down this proof if you think for a little bit. Okay. Vedant, question?
Yes, sir. What if we want to prove root 12.25 is an irrational number? Using this, we will prove it is irrational.
It's
No. So square root. Okay. So this is also a very good question. In fact, I think this also came up in the other batch. What if we use this proof technique and try to show that this is irrational? Okay. What if we use this? Will the proof go through? And if the proof will go through, then does that mean that this is irrational? Because we know that this is nothing but this is a rational number. Okay, so let's say that somebody tries. Let us prove that square root of 12.25 is rational. No, is irrational. So you will say assume root 12.25 is rational, which means 12.25 is equal to P square by Q square, which means 12.25 multiplied by Q square is P square. Say, hey, this is 3.5 Q, the whole square is P square. So our assumption is correct. So it is an irrational number. So then we know that this is not a rational number. So here you see the proof does not go through, it gets stuck here. In fact, there is an interesting problem which I would like to show you. Okay, I'm not going to discuss this problem. I leave you to find out what is the problem or what is the bug in this problem. Okay, and maybe some of you have seen this problem, but you can still enjoy. So I have a triangle. This is some triangle. Okay, some triangle. What I do is first is naming ceremony. I name it as triangle ABC. Then I draw the perpendicular bisector of BC. Okay, this is the perpendicular bisector of BC. Let it meet at point D. And then I draw the angle bisector. Okay, assume this is the angle bisector. So it meets this at E. I'm lowering your hands. Okay, and then from E, what I do is I drop a perpendicular to AC. I call it EF. I drop a perpendicular to AB. I call it G. I'm saying now, let me connect a few things. Let me connect BE and EC. This is what I'm going to do. I take triangle AGE. Davin, you have a question or a comment?
Sir, is BEF going to be a straight line?
Not necessary. Not necessary.
BEF and GEC.
Not necessary. At least nothing is given, so you don't assume that it is going to be a straight line. So triangle AGE is congruent to triangle AEF. Can somebody tell me by which test?
Sir, AFE.
Okay, yeah. If you, yeah. So
Sir,
AFE.
I mean AS.
So this is ASC. No.
ASA test, or some of them may call it AAS. I don't want to debate on that. So these two are congruent. So from this, I can say that GE congruent to EF, right? This is point number 1. Now I have triangle BDE congruent to triangle ED or CDE. B. Can somebody tell me which test?
RHS test.
No.
SAS.
SAS. The moment we see a right angle, we don't have to think that it is always RHS. So this is a common side, right? So we have S side angle side test. Now I say BE is congruent to EC. Okay. Now I take triangle BGE and I say that is congruent to triangle CCFE. Okay, by which test?
So there's one angle.
ASI.
There is one side equal and
this side is congruent to this side.
Yes.
This side is congruent to this side. RHS. This time it is RHS test. Now I know that angle GBO is congruent to angle F.
Sir, where is O?
Sir, where is O, sir?
Sir, E, sir.
Not E, sorry. GBE. GBE is congruent to angle FCE. And then I also know that angle BB, wait, ABG, PG, yeah, angle G, where is it? Okay, so angle G, wait a second. Angle G, oh, sorry, just 1 second, just 1 second, hold on.
Sir, you can mark it in the diagram.
Just a moment. So angle GBE, yeah, this is congruent to this. And then I know that angle EBD, angle EBD is congruent to angle ECD. EBD, ECD, right? Let's say this is my point 4. So from 3 and 4, 3 and 4, from 3 and 4, what can I conclude?
Sir.
Ah, yes. Therefore, triangle ABC is Ali, hold on. ABC is isosceles, right? So, Davin, what is the claim that I'm trying to make?
Every triangle is isosceles.
Every triangle is isosceles, right? So, claim.
Sir, we can do it 3 times and tell every triangle is isosceles.
Quiet, wait. Claim every triangle is isosceles. Yay. Groundbreaking theorem of mathematics. Smithali, wait, I know what you are going to say. Dhirav, you agree every triangle is isosceles?
I don't think.
You have to say yes. You don't have a choice. Yeah, otherwise you have to find a bug in my proof.
Sir,
Who's
can
that?
you please gist out the proof again just one time,
Sure. Who is asking this question? Anirudh.
Yes,
Anirudh. Anirudh, see, first I prove 2 triangles congruent, okay?
with ASA, okay, sir.
Yeah. So AGE, this triangle is congruent to this triangle. And then I move on to show that triangle BDE, this triangle is congruent to this triangle. And then I move on to show that this triangle is congruent to this triangle. I'm showing one triangle is congruent to another, and then I take something out of it. You see, I take this out of it. I use that to show that the next triangle is congruent. I take something out of it. And using these two, I show that the third case, these two are congruent. And from there, I take out the angles which are congruent. And then I show that every triangle is isosceles. Right? Yes. If anybody feels like touching my feet, yeah, feel free. All right. So, I mean, this is nothing great. This is not my proof. I got this proof somewhere. But Ritvik, you have a question? Say yes or no.
No. I think I have a comment. I'm not sure about it, but
okay. Hold on to that. Hold on. Malay, question or comment?
No, sir. Comment. I mean,
do you think your comment will lead to the answer?
Yes, sir. Why this proof is wrong?
Wait, don't say anything.
Okay,
Dhirav.
Yes, sir.
Yes, you agree with this, or you have a comment or question?
I think I agree with this, sir.
You agree with this. Thank you, Dhirav. You are my only friend. Parth?
Sir, I think I know why the problem.
Okay. All right. So, Shaurya?
A comment, sir.
Comment. What is it, Shaurya?
So I do not think it will lead to a solution, but what I think is that it is not necessary the angle bisector and the perpendicular bisector of another side must intersect.
Must intersect? They will intersect. Otherwise, they will be parallel, right?
1 second. Let me write this.
Sir, or maybe they intersect outside the triangle.
Outside the triangle?
Hey,
Omkar.
show you one triangle which they intersect.
For scaling triangle.
Who said that?
No, sorry, I take that back.
Okay. Omkar, is everything okay with you? So yes.
So I'm just trying out all possibilities. Which one you'll say
Okay.
yes?
Smithali.
Sir, yes, the figure is not worth believing because it is incorrect. We lied in the exterior. And
Yeah.
I would like to add up that this kind of question was in the promise application problem set, so I can never forget this kind of questions.
Oh, really?
Yes, sir.
Sir,
Sir,
I
it was
think
in the Journal of
One second.
Irreproducible.
Let Smithali finish. Yes, Smithali.
Sir, it was from the Journal of Irreproducible Results is what they had said, and it was that every angle is a right angle. And it was a similar question in which they had taken a point in the interior, but we had to find the flaw. And moreover, I was glad that I was able to generalize, and I found many more things. Like I used it various methods, so it took complete of 4 to 5 days. So I can never forget that.
Smithali, would it be possible for you to write down, some of those bogus proofs and share?
Sir, I can share that one, like why it is not true, and because I have done it very neatly for the promise.
No, don't say why it is not true. Write down the bogus proof like this and let others figure out like that.
Okay.
Okay. So like Omkar and Smithali said, guys, this what is wrong over here is because what is wrong over here is a cheating that I made. That is, I made you believe, or you just believed this image that these two will meet inside. But actually, if you take a scalene triangle, then you will see that if you draw the angle bisector of this one, it's going to be something like this, and the perpendicular bisector will be something like this, and the point of intersection will be outside. Davin?
Sir, misleading images. We talked about this today morning.
Sir, what
Davin?
about equilateral?
What about equilateral? Equilateral is everything, there is just one point: altitude, median, perpendicular bisector, angle bisector, everything goes through one point. So ideally, if this was, let's say that somebody wants to check if every triangle is isosceles or not,
Equilateral triangles are already isosceles. So what's the point?
and then if they want to do this, ideally it should have been 3 cases: either the point of intersection is inside, or it is outside, or it is on the triangle, right? On the triangle. And then we can argue. So this is the flaw in this. So what is wrong over here? The assumption. We started with the wrong assumption. What was the wrong assumption? The rough figure, that this is true. So what I'm trying to say is, if you try to do something bogus like this, which came up here, that is, what if somebody said, no, 12 point root of 12.25, and if you try to do a bogus proof, you will hit the wall somewhere. Okay, all right, a few hands are raised. If you don't have any further questions, can you lower your hands?
So this kind of proof that you did will only work when you're doing it by hand. If you're doing it with some online calculator which does everything automatically, it won't work.
Yeah, but then we don't go, so the idea is, what is to, if our brain can find a flaw, right? I mean, if we have a software that can do, then why do we need our brain? Right? We are doing it as a mental, like a math proof. Achyutan, question?
Yeah, sir, we can actually use this fact to prove that the perpendicular bisector and what do you call it, angle bisector meet outside the triangle. We can
For
do
a
proof
scalene
by
triangle.
Yeah, for a scalene triangle, we can do proof by contradiction.
Yes. So if the question is prove that this meets outside, and you want to, very good point, Achyutan. So if you want to show that, then you can disprove that this is not possible to meet inside, and then you show that it is not possible to meet on the triangle as well. So there leaves only one possibility, that it has to meet outside. Good point, Achyutan. Parth, question? Omkar, question?
Sir, I've seen like a bogus proof where they prove 1 equal to 2. and then because they
Yeah.
use infinity and they do some
No, it is
multiplication.
in that proof. It is common sense. There is no rocket science over there. You just divide by something like a
You divide by
minus b.
0.
Yeah, sir.
Yeah, you
Cancels.
divide by 0. Yeah. Okay. All right. So I have another question. Let me take another question in contradiction. Let me just see which one. Okay. So let me ask you, if I add a rational number and a rational number, will I get a rational or irrational number? Rational or rational number. Okay. I have a rational number plus an irrational number.
Irrational, sir.
Irrational.
Irrational. Okay. Prove this using proof by contradiction. Okay.
Sir, all these contradiction to use to prove these irrational numbers mainly all we have done in school, sir.
Oh, you have done this problem?
Yes, sir. Class 9 NCRT 9th and 10th first chapters. Maths.
Oh, really? You had this problem? Okay.
Yes, sir.
Yeah.
Okay. So let's take another one. Let's take this problem maybe to prove using proof. I mean to do
Sir, I have
using
a question, sir.
Yes. Who's that?
Sir, it's Omkar.
Omkar.
Sir, pi is irrational. So if you take and the circumference of a circle is rational and the radius is also rational. So if you take 2 pi r, how does that become rational?
My dear, when a circumference is you say that circumference is rational and radius is rational does not make it rational. Omkar.
Can't just tell update and
by Omkar's theorem.
Sir, but it is, how can it be rational? I mean irrational.
Why can't it be irrational? Why can't it be?
if you can show one case of where the radius and circumference are irrational, I mean rational, I believe.
Everybody will, every mathematician will resign and they'll come at your doorstep to meet you, Omkar. All right, so let's do this. Prove that. Okay, read the 10th question. Let me increase the.
So what is that ultai?
Yeah. This is the symbol for all values of. You see the last point. Note. For all values of. Prove that for all values of n or for all n where n is an odd integer, there is no circular arrangement possible for n boys and n girls such that there exists a person whose both neighbors are not girls. Again, prove that for any value for n where n is an odd integer, there is a circular arrangement. There is no circular arrangement possible for n boys and n girls such that there exists a person whose both neighbors are not girls. That is, there exists a person whose both neighbors are not girls. This is not possible. Very complicated. In other words, prove that no matter how you arrange n boys and n girls in a circular way, there always exists somebody whose both neighbors are girls. This is what it means. But the reason, 1 minute, Parth, I'll come to you. The reason I gave these two statements is because there is a play of logic over here, negation of negation kind of thing. And, while reading, people may get confused. So, Parth, go ahead. Question?
Yes, sir. So I don't think the statement of the question is correct because we have to prove that there exists a person who's there's no circular arrangement such that a person has both neighbors, not girls. So, sir, it means that each person has at least one neighbor, which is a girl. But, sir, in other words, they have said that there always exists someone whose both neighbors are girls. That is not necessary.
No matter how you arrange, there always exists somebody whose both neighbors are girls. That means, okay, let's take
both need not be girls, right? At
one
least
second. Let us take maybe 3 boys, 3 girls, right? 3 boys, 3 girls. Now you can arrange them in different ways. Suppose you put boy, girl, boy. Now you cannot put a girl, because if you put a girl here, then you have a person whose both neighbors are girls. So you put a boy, right? Now maybe you can put a girl, but now you have to put another girl, right? You put a girl here. So here is the person whose both neighbors are girls. So what this statement is saying is, no matter how you arrange n boys and n girls, as long as n is odd in a circular way, there always exists somebody whose both neighbors are girls. I think your doubt is in the first statement, right, Parth?
Yes.
Others, those who are saying, just hold on. So what it says is that there is no circular arrangement possible for n such that there exists a person whose both neighbors are not girls. So there is no circular arrangement possible that there exists a person whose both neighbors. Okay. Are you saying this should not be not? I mean, this not should not be there?
Yes.
Okay. There is no circular
no,
arrangement.
sir, I'm not saying that.
Then?
So I'm saying that there is no circular arrangement in which, even I'm not sure how to say it.
Okay. Panchul?
Sir, like, or there, if according to the question, if we have a circular arrangement, there is no circular arrangement such that we will have a boy whose both neighbors are not girls.
Sorry, what are you trying to say? This is correct or this is not correct?
I am trying to say this is not correct.
Okay, so
Then what if n is 1?
Like, sir, like for example, if we put 3 girls together and 3 boys together, then no boy will have 2 girls.
Who is saying that a boy should have girls as neighbors on either side?
Sir, I think you should make it
But 1 second, Omkar, wait. I'm talking to Panchul. Panchul, is it said that there, when you say person can be a boy or girl, no?
Yes, sir. Okay.
Yes, Omkar.
Sir, so you're saying there is no, I think this is wrong. There's no circular arrangement possible for n. So you're saying what circular arrangement is not possible? That there exists a person whose both neighbors are not girls. But just now we did, one person was there whose both neighbors were not girls. I think you mean all people.
No, there exists a person. There is no circular arrangement possible such that there exists a person whose both neighbors are not girls.
Sir, so just now we did, there was a person whose both neighbors were not girls. So you're saying that there exists no, so we did an arrangement. In that arrangement, there was a person.
Okay, so let me rephrase. There is no circular arrangement possible for n boys and n girls such that there exists no person, should not be a person. There exists no person whose both neighbors are not girls.
So we've already said no at the start. So
sorry, say that again.
So we have already said no at the start. There's no circular arrangement. So
no. Okay, so
sir, there is no circular. You made a mistake, sir. I think before it was all right. Why to have 2 no's?
Why to have?
So my problem is
like when you keep a no there and no person with both neighbors not girls means no person with neighbors both girls, right? So A will be appropriate, right? Why should you change? I don't think
a person. Okay, so we'll one second. We'll debate about this. Let me just get this clear. Is this clear? In other words, you need to prove that if you have an odd number of people, you can always find somebody whose both neighbors are girls. And somebody said you put a girl, and then you put a boy. So this is that person whose both neighbors are girls. So we can also say that there exists at least one person. So when you say a person refers to, there exists at least one person. Okay. It doesn't, does not refer to only. there exists only one person, because you can arrange B, G, B, G, B, G.
Sir,
So
I
if,
found
if
the correct thing.
1 second, Omkar. So here you have 3 people whose both neighbors are girls. So that means if you arrange 3 boys and 3 girls, you can always find somebody whose both neighbors are girls. And this is what we need to prove by contradiction. Okay, we need to prove by contradiction.
Sir, you could change it to, instead of a person, to all people.
What all people here?
No, in the question. Yes.
No, sir. For n boys such that I don't see how all works there. I mean, let's do one thing. Okay, so this maybe it can be rephrased, but at least if you are good with this, let's just proceed with this. We have about 10-15 minutes. See how you can prove this by contradiction.
Sir, so we have to prove that the neighbor of a boy will always be 2 girls.
I know I didn't say a boy. It could also be a girl, right? There exists somebody whose both neighbors are girls. So in this case, it's a girl whose both neighbors are girls. In this case, there are 3 of them. In this case, there is 1 boy. The question is, no matter how you arrange, you will always find somebody whose both neighbors are girls. If n is odd, if n boys and n girls, if n is odd. Ritvik, question?
Yes, sir.
Tell me.
So if we were to do this with induction, like we cannot say k plus 1, we have to say k plus 2. Because then it will be...
K is the number of boys and k is the number of girls, right? So you can increase 1 boy and 1 girl. Yeah.
So then the number
No,
of
then
boys
it
and
will become
girls will
even. Then it will become even number of girls and boys.
Yeah. So we'll have to add. So the next case would be k plus 2. Correct.
So induction, like what it says, is wrong then.
No. So k and k plus 1 is just for our understanding. That is, k is the case and k plus 1 is the next case. So in this case, there is no k. The k plus 1th case is actually 2 numbers forward.
Yeah. Okay, good.
Parth, Davin, if you don't have questions, can you lower your hands? Achyutan, you have a question?
Yeah, it's not a question exactly. It's a comment I have to make. No,
Tell me.
It's like leading to the solution. So here, suppose we have an arrangement where there exists a person who has both neighbors as boys. We can just flip the genders of all the people. So that arrangement will have that same person will have a gender. What do you call it? We'll have 2 partners. Both of them were girls. So basically, what that means is that there can never all people have neighbors which are have neighbors, 1 boy and 1 girl. Because suppose a person has both boys as neighbors, then we just flip the gender of everybody, and then we'll get.
No, why do we have to flip the genders of everybody? You have somebody who's both boys, neighbors are boys. Good, no?
No, I'm saying that will lead to a contradiction to our claim, because we say that exists no such arrangement. So if we flip all genders, that's also a valid arrangement, right?
But we are not taking that particular arrangement.
No, but we say for all. Oh, okay.
So we can
basically prove that there exists not even one arrangement. So
exactly. Yes. There exists, even God cannot arrange all these people in such a way that if everybody looks towards their left and right, you see either 2 boys or 1 boy, 1 girl, but never 2 girls. Smithali, you have a comment?
Solution.
Solution, okay. Can you try induction and pigeonhole principle as well?
Okay, I will try.
Yeah. Others work. There are a lot of messages that came on chat. I think I'll have to look into that. Can you see that there are always exist at least one person who's both neighbors? Yes, Sohalia, you are right. You can say that. Devin, I saw your message just now. Yes, you are correct. I hope you are able to prove it. Okay. Pakistan, I saw your comment. We'll discuss this after the class, okay? Right. Okay, Smithali, go ahead.
Yes, sir. Sir, let's assume that it is true, and there be 2k plus 1, 2k plus 1 girls and 2k plus 1 boys. So
Okay,
we
assume
remove
that we have 2k plus 1 girls, 2k plus 1 boys. Then
yes, so now we remove the additional 1 girls to get it 2k girls and 2k boys just for some time.
okay, so keep one boy and one girl aside.
Now the only way possible to arrange them such that now it is equivalent to say that because in the question it is not anyway there is something extra given for girls or boys, so it is equivalent to say that we cannot have a person with 2 adjacent girls. We cannot have this case, girls or boys, so it is equivalent.
Sorry, I'm a little lost over there, but before that, assume that we have these many girls and these many boys, and an arrangement such that there exists nobody whose both neighbors are girls. Smithali, continue.
Yes, so now if here in the end there is girls, so if we change it by boys, then also it makes no difference because it is.
I'm lost, Smithali. You will have to say a little slow. I take away one boy, one girl. I understood that.
Yes, now another thing is that if instead we have written this statement, so if here instead of girl in the last line, we replace it by boys, it won't make a difference because it is without loss of generality.
Okay, so?
Yes, so now the only way to arrange this 2k girls and 2k boys such that there exists nobody where the both neighbors are girls or boys is that we arrange them in pairs like boys, boys, girls, girls, boys, boys,
Okay.
girls, girls. Like
Okay. Okay, just hold on. So what Smithali is saying is take away that extra, one boy and one girl aside. And if you arrange them in pairs like this, then it works because you put a boy first and then you put, let's say, a boy, and then you can put a girl and then you put a girl again. This works. So this goes on and finally you have a girl, you have this. So here you have 2k boys and 2k girls. And then
rather this is the only arrangement possible with the given condition, because if we say do alternate anywhere, then we will obtain something which will not agree with our statement.
Right.
So
So
this is the
what
only
she's
way
saying
possible.
is if you swap any two persons, then what is going to happen is you will get the boy here and girl here, and then this guy will become the person whose both neighbors are girls. Or if you swap any boy with a girl, let's say that you put bring this boy here and bring this girl here, again it is going to happen. So this is the only arrangement possible. Proceed.
Yes, so now we have to insert one boy and one girl. So say for instance, I instance that one boy between two boys.
Okay, so if you say that you put one boy between two boys,
then I'm having three boys in a line, and as I had earlier said that there exists nobody whose both neighbors are girls, or we make it boys, it doesn't matter because it is same. So again there are three boys in a line, and then that would
no, you cannot make, so I agree with what you're saying, but are you making two assumptions?
no sir, sorry, that was wrong. Leave that. We take the girl. So now we insert the girl between two boys, or between two girls, or between one girl and one boy.
Okay, so our options are you have three boys, or you have boy, and a girl here. You have something like this, or you have a sorry, girl, boy. This is the only possibility, right? I mean, you can have a girl, boy, something like this. Now the thing is,
yes, so we will have something like this, and now we have to insert a girl over here. So say I insert the first girl between a girl and a boy.
okay, here.
Yes.
Okay.
Then note that before this girl there is going to be a girl, because we have arranged them in pairs. So then there are three girls in a line, and therefore there is somebody which has both girls. Then
So
similarly,
you cannot put them here.
Yes, if we insert them between two boys, then again one beside the boy is girl, because we have arranged them in pairs. So again that doesn't. Then that it we arrange, and if we then put them between two girls, and again it is three girls in one.
So there are three possibilities. You can put the girl between a girl and a boy, or between two boys, or between two girls. Between two girls doesn't make sense because you are already making it happen. If you put between a boy and a girl, then you are having this girl who is between two girls. If you are putting it between two boys, you have these two girls, and hence, that hence what? How do you finish it, Smithali?
Hence, there is a contradiction to our assumption.
Hence, there is a contradiction. What is the contradiction? We have found one pair, or not one pair, found a person whose both neighbors are girls.
If we make it, if we make the number of boys n+1, then it will maybe work.
Yes. You think so?
Yes.
Because as long as it was boy is one more than the girl, then it was, it was kind of working, right? All right. Malay, question?
No, sir. Another way solution.
Using contradiction, is it?
Yes, sir.
Go ahead.
So suppose for the sake of contradiction, we assume that there is no arrangement such that no person will have both neighbors' girls. Sir, it's just similar that there would be no person such that both neighbors are boys. So the only possible arrangement would be boy, girl, boy, girl, ... So we get that number of boys and number of girls is even, but it contradicts our given statement that number of boys and number of girls is odd. So our
no, I think that will still be incomplete, because how do you say that this is the only thing possible? And okay, so if you say that for 2K this is the only thing possible, I'm okay with that. But you will still have to argue that you have that extra person, and where will you place them?
Oh, okay.
Don't you think so?
Yeah. Yes, sir.
Okay.
Thank you, sir.
Welcome. Parth, question?
I have a doubt in the first proof. So
This one?
Yes, sir, that one. So I got the proof, but I is it a proof by contradiction? Because sir, like if we don't even assume that that the statement is false, we can still do the same operations and
Yes.
get
So like I said,
answer.
we can have multiple ways of doing this. And in fact, I said this earlier, right? We can do this by pigeonhole principle, which is a proof technique. We can do this by induction. We can do this by contradiction. There are different.
So what is the pigeonhole?
One second, Omkar. Parth, say that again.
So why is this method a contradiction method? Because we just directly prove it.
So we are assuming that there exists an arrangement, right? We are assuming that there exists an arrangement, and we are coming to the point that, oh, I'm not able to make that arrangement. So my assumption is wrong.
Sir, but if we suppose don't make that assumption, then still we can do the same argument.
Yes, then it will be proved by deduction.
Okay.
So the way in which we wait, so it will be deduction in that case, Parth. Okay. Omkar, what is pigeonhole principle? Pigeonhole principle, I mean, had we had time, we could have discussed that, but maybe next year. Pigeonhole principle has a very simple statement, that if you have n number of holes or pigeonholes, and n plus 1 number of pigeons,
Sir,
and
this
you
is kind
put
of an obvious
every
statement,
pigeon.
this principle.
Sorry, say that again.
Sir, this principle is kind of an obvious thing only, right? Just not much complication or anything.
Yes. But the thing is, okay, so let me just share my 2 cents of why do we have to name something, give a fancy name to something which is common sense. Okay. So what pigeonhole principle says is, if you have n plus 1 number of pigeons, and if you have n number of pigeonholes, and if you put every pigeon in a hole, okay, there exists at least, or rather there exists a pigeonhole that has more than 1 pigeon, right? That means you can keep a pigeonhole empty, and you can put 3 pigeons in another one, and go ahead. So no matter how you arrange, there will be at least, if you put 1, so finally there will be 1 extra which will go somewhere. So this is the simplest thing to understand in terms of proof. Why do we need something like this? Because when we write a formal proof in mathematics, we need to state what idea are we using, according to what, on what basis are we arguing. So for these bases, there are different names given. So deduction is, all these comes from Greek mathematics. Okay, the way to argue and things like deduction comes from, I think, Aristotle's principle. I'm not very sure Aristotle's laws. So in that, one of the law is something to do with deduction. When we say induction, proof by mathematical induction, there is somebody called as Peano's axioms, and deduction is one of the last axioms in Peano's axiom. And there is contradiction. Contradiction comes from Boolean algebra, that is logic. And again, there is Morgan's laws, Morgan's laws, by which we learn this negation thing. And there is something called as contrapositive. Contrapositive is, if we know that P implies Q, you can prove that Q implies negation P. If you prove this, then that is equivalent to P implies Q. So that is contrapositive, which is very closely, and one might confuse that with contradiction, but that is something different. So each of them, I mean, this also comes from De Morgan's law and all that. So all these are actually some laws or axioms based on which there is some kind of this thing. I don't know the history of pigeonhole principle, or is it just a common sense thing. So we have to say on what basis are we saying this? Is it deduction? Is it induction, contradiction, contrapositive, pigeonhole principle, combinatorial proof, or what? Okay, Rituparna.
Sir, I have a doubt in the in that proof in which we had to prove that root 13 is irrational.
Okay, hold on. I'll come to you. Parth.
Okay.
Sir, I didn't understand contrapositive.
Contrapositive. So contrapositive is, suppose you want to show that, let's say, r raised to 1 by t is irrational if r is irrational and t is rational. Okay. So what we are saying is, if r is irrational, this is the statement, if r is irrational and t is rational, then r raised to 1 by t is irrational. So it's a if then statement. If this, then this. That means if you say r is irrational and t is rational, then that implies that r raised to 1 by t is irrational. So if you want to prove this by contrapositive, what you do is you want to show p implies q. So what you do is you take negation of q. Negation of q is negation of this statement. That means the r raised to 1 by t will be rational. And you show that if that is rational, that implies that what is the given statement? This statement is false. You show that this statement is false. So if you are able to show, that is what negation p is. If you are able to show that, then you can say that I've proved this using contrapositive. That is, you take negation of that. I mean, that will take away at least an entire session. Okay. But this is a high level, I mean, just an idea about this. Ritvik.
Sir, 1 second.
Sir, so in this r power 1 by t only, why would we try to prove it? Isn't this false? Like, so because if r is irrational, if you take an example like root 3 power 1 by half is 3, and it satisfies all the conditions.
T should be an integer.
Yeah, t is an integer. Sorry, t is not rational. T is a integer.
Okay.
Sorry,
Okay.
sorry, my mistake.
Yeah,
T
sure.
is t is an integer. Yeah.
Okay, got it.
Okay, all right, guys. So Rituparna, stay back, and those who have any other questions, you can stay back. Okay, so I have a comment from a friend of mine who's attending this, who gave the name PHP. It was Shiv. How do you pronounce it? I don't know the mathematician's name. Can you say that?
Even I'm not sure about the pronunciation. Dirichlet is how I pronounce it, but I'm sure
Dirichlet. Okay, can you put it to everybody, the name, and then maybe they can look it up? Yeah, thanks, Shiv. So yes, so that's all, guys. We can take a pause here and we'll meet in the next session. So tomorrow